technique. Anyway, there we go. So we're going to start to do what's called trigonometric substitution here today. So at least to get you started for the weekend. And you might say, for example, what is trig substitution actually used for? Okay? So trigonometric substitution, trig sub for short. Well, let's spell it all out, okay? Trigonometric substitution. Okay? So you might say, when do I use a trig sub? Well, when your integrals involve functions that have the following kind of statements, okay? Square root of, for example, a squared minus x squared. Let me do this. So if your integrals involve a squared minus x squared, I'm going to see which ones we do first. Yes. Square root of maybe a squared plus x squared, or the square root really of x squared minus a squared. Okay? So whenever your integrals involve these types of integrands, you're going to use what's called a trigonometric substitution. Okay? This is going to be referred to as, we call that like case 1. We'll call this case 2. And we'll call this case 3. So this is generally speaking, okay? So in general, you have these cases here. And they're all different, but this is kind of the starting point for what's called trigonometric substitution. Okay, now each one of these, as you guys know, has this like a value here, okay? There's an a value there, and yes, you have this x value, and they're both squared. And in some cases, you have sums. In some cases, you have differences. Okay? So generally speaking, we're going to look at how to do this. Now, what happens is this. Your trig sub essentially converts. So this kind of substitution is going to convert, you know, you're going to convert these integrals to a trigonometric, a trig integral, the stuff that we've been learning, okay? So you're going to convert to what we call a trig integral. And you say, what do you mean trig integrals? Yeah, that's 8.2. So trig integrals are an 8.2. This is actually an 8.3. This is what we call, you know, doing a trig substitution. It's kind of like a U sub, but it's trigonometric substitution. So like, for example, here, I'm going to do a quick kind of example. Maybe, let me double check. I'm going to make it up. What happens if you have to integrate something like this? 4 squared minus, well, not 4 squared. We'll say this. Got to be careful with this. Well, I'll do what I have already. I don't want to make it up. If I do, who knows what'll happen. But okay. But let me double check, because I might want to just do some other different one. And that's always good too. Try to do a simpler version just in case. And maybe not. If you try to simplify it, it might not be a very good idea. Okay, I'll just try this. Or maybe, no, let's try to do a simple one. I apologize. Maybe just say 1 minus x squared dx. Hopefully that's going to be a nice and simple one. Okay? All right, so as you guys can see, you might say, what am I really looking at? I'm looking at which one of these cases here, right? You have an integral with a radical. So which case would you guys say this is? 1, 2, or what? 3. I'm going to say case 1. Good. How could you guys say it's case 1? Yeah, and you say, don't I have to have an a squared minus x squared? Well, okay, well tell me, can you think of 1 as really 1 squared? You guys see what I'm saying? So in that case, what do you guys know about a? What does a equal? A is 1, is that true? Okay, because you're looking at this case 1, yes. So you're going to have to identify what you're looking at. Easy peasy lemon squeezy? So far so good? Alrighty. Okay, now for case 1 type of integral, we're going to have to talk about what you guys do now. Okay, so for case 1, when you have the square root of a squared minus x squared, like in this case, this is your substitution you guys use. You're going to substitute now for x. You're going to let x equal a sine theta. Okay? So in our case, what does that mean about x? Since a is 1, we can say, do I have to use 1 sine theta? Well, yes, but 1 times anything is itself. Is that right? So for our integral here, we're going to substitute for x, what? Sine theta. We're going to make this trigonometric substitution here. Okay? That's going to be how we start. Now, if you have x is sine theta and it's a trig sub, what you need is dx d theta. Okay? Because we're going to do a substitution. We're going to change the variable from x to theta. And it's really going to be a trig integral. So what's the derivative of sine? Is that cosine? Okay. So what your book will say is this. If x is a sine theta, dx is a what? Cosine theta d theta. So in this example, in blue, dx is simply cosine theta what? D theta. Okay? So you're going to do a trig substitution here. Now, what really always happens here is what becomes, ladies and gentlemen, of the radical here. So focus on this. Because you're converting this radical to really a trig function. Okay? Now you say, what do you mean? Yes. Let's focus on the radical. Okay? So I want you guys to notice here, this radical is going to be what? 1 minus x squared. Is that true? Well, what happens with the x? You're letting x be sine theta. So that's 1 minus what? Sine squared theta. You guys okay with that? Okay. So then now you're going to use the Pythagorean identity for 1 minus sine squared theta. What is 1 minus sine squared theta? What do you guys get?
Cosine minus 1.
Isn't that cosine squared theta? Pythagorean identity? 1 minus sine squared theta? So far, so good? What's this the definition of? If you have the square root of anything squared. You guys know what that's defined to be? That's the absolute value of what? Cosine theta. Now, here's what you're going to need to know. You're going to now have to look at, essentially, theta is going to be between 0 and what? Pi over 2. Okay, it's thought of as being quadrant 1 for cosine. So you say, what does that mean? Well, what that means is my radical in purple is really going to be what? Cosine what? Theta. Okay, you guys okay with that? So the radical gets converted to cosine theta by this trig substitution. So let's put everything together. Now, here's what the book is going to say, just so you guys know. If you convert a squared minus x squared, in general, that's going to be a cosine theta. Okay? Because they're going to have a be, well, a is going to be positive, but okay. So in this trig substitution for case 1, you're going to replace the radical. The radical is just going to be what now? Cosine theta. So far, so good? Because that's what you proved. In purple, that's just cosine theta. But what do you need now? You need what here? What's color? What is dx? Dx is what? Also cosine theta, but it's cosine theta d theta. Okay? So what does that give you then, ladies and gentlemen? So you're going to do this. You're going to convert radicals that look like this. This becomes cosine theta d theta. Now that integral is really what? Cosine squared theta d theta. Okay? Now, here's the deal. This is known as, what do you guys know this as? Here's my point. This is known as a what? Trigonometric what? Integral. So you are going to take integrals that involve these kinds of radicals, and you're going to make the appropriate trigonometric substitution, because you're going to convert these integrals to what? Trig integrals. The trig integrals you studied in section 8 point what? 2. Okay, now I wish I had my sound effects, because what I would do is I would do what? I'd hit the applause button, and that's why you guys want to do homework on trig integrals. Because how do you now integrate what? Cosine squared d theta. Are you going to wait till the night before to do a homework on a trig integral? I would say no. By then it's too late. You know what I usually tell students? You might as well just go to the movies and have a nice dinner. I don't know. Why are you going to do that the night before? Who does that to themselves? I wouldn't do. That's like trying to lose 20 pounds the night before you get married, because you want to get in that wedding dress, or you want to get in that tuxedo. Do you guys know? Can you ever lose 20 pounds the night before your wedding? Can't do it. So are you going to learn everything the night before a test? Can't do it. So this assumes you know how to integrate cosine squared theta. How do you integrate cosine squared theta? Anybody know? What do you guys use again? Yeah. What's the identity? 1/2, 1. 1/2, 1 what? Plus or minus? Is it cosine double theta? On a test, am I going to give you that cheat sheet? Yes. What do you guys know about that cheat sheet? What is this one? Is it plus or is it minus, ladies and gentlemen? Cosine squared theta. You guys know this one's plus. Sine squared is minus. So we actually integrated, as an example, sine squared. On the homework, they might have had what? Cosine squared. So pull out the 1/2 now, and now you got 1 plus what? Cosine 2 theta d theta. Is that true? You guys with me on that? And you want to know what this gives you? What does this give you? 1/2 theta. Can you integrate cosine double theta? What do you guys use? What is it called here? U sub. Okay. What does that give you? You guys know that integral? What's that one going to be? That's 1/2 what? Sine double theta. And then what do you do here? Distribute. And ladies and gentlemen, take a look here. Yes, I know there's plus what here? Plus c. Okay? So, you know, this is how you integrate cosine squared theta here. Okay? So you go, oh, okay, good. I got cosine squared theta. Yes. But what's the problem, ladies and gentlemen? What's the real issue? That's not the integral they gave you. You have an integral in terms of theta. You got an answer in terms of theta. Is that right? What's the problem? Yeah. This is like the antiderivative, right? This is big F of theta, the antiderivative. What do you need? Do you guys know what we need our answer in? The antiderivative has to be in terms of x, not in terms of theta. Okay? So what do you do now? Do you guys know what you do? Here's a question. How can we do what? Convert back to the x variable? It's a question. We got to convert back to the what? X variable. How do we do it? Go back over here. What does x equal anyway? Do you guys know what x is? What is x? X is sine theta. Is that true? Okay, you guys okay with that? Now, what I'm going to do is this. I'm going to say this. I'm going to remind you guys that we can say sine theta is x over 1. Is that true? What am I doing? Because theta is in quadrant 1. Remember we said that? Theta is in quadrant 1. Theta is between 0 and what? 90. And in fact, it can't be 0 or 90. It has to be a right angle there. Okay? So in other words, this is a right triangle here. You guys know what I'm saying? What's the definition of sine? Anybody here skip trig by any chance? I hope not. I hope not. What's the definition of sine? Isn't it opposite over what? Hypotenuse. So in other words, this is x, and this is 1. Do you guys know what this is going to be? It's going to be that radical, square root of 1 minus x squared, by Pythagorean theorem. Okay, and then this is the adjacent side. Okay, you guys okay with that? So this goes back to geometry or even trig. Okay, you guys know what I'm saying? So you're going to go back and say sine theta, yes, was opposite over hypotenuse. Now you say, what does this mean? Well, what do I have, ladies and gentlemen? You see all of this here? I'm going to have to use, again, some trigonometry. So I guess, you know, it's called trigonometric substitution, trigonometric integrals. I guess they want me to remember some trigonometry. Is that right? So what I'm going to say to you guys is this. This is which we have to I'm going to try to color coordinate this. I need theta, and I actually need sine 2 theta here. And I have to deduce it from this information that we know. That comes from this right triangle, okay, in trig. Now, if I said to you guys, how do I get theta? I can get theta. How do we get theta? Well, go back over here. Sine theta is x. Is that true? What is theta? Bless you. If sine theta is x, what is theta? Anybody know? Inverse sine of x. So let me go to my website here. Oh, there's the website in trigonometry. You guys know I have all these videos on all that stuff. You guys know what I'm saying? Man, look at that. Let's say there's the power reducing identities that we worked with. Power reducing. Anybody watch them by any chance, the power reducing videos? I kind of put this wasn't just for the trig students. You want to know what I really did it for? The Calculus 2 students. You say, why did I do it for Calculus 2? I've been teaching Calculus for over 20 years. What happens? People come taking Calculus 2 without Calculus 1 and trig. So this is why I did it. And then, oh, what do we have here? Inverse what? Trig functions. I have lectures on the inverse trig functions. So in case you want to review that too, there it is for you guys. You guys know what I mean? All righty. Good job. So I want to remind you guys, there it is. So theta is really what? Inverse sine. And then you say, Mr. Judge, what do you do with the sine double theta? Well, go back to trig again. Darn it, that trig. I'm here. You know what I have here? This is something that in trig classes, historically, a lot of students don't like proof. They go, oh, proof, and they hate it, and proof. Well, I got video even on proof and logic, because a lot of that was even done for sign reducing, you know. You use a bunch of identities. But let me ask you guys this. Let's go back to, this is kind of was having trouble this morning. Oh, trig cheat sheet. Here's what you guys are going to use. There's an identity for sine double theta. It's right up here. What's sine double theta? Do you guys know? What's sine double theta? 2 sine theta cosine theta. You're going to use that identity. 2 sine theta what? Cosine theta. This identity, ladies and gentlemen, is the same there. So you already know what sine theta is. What's sine theta? What's sine theta, ladies and gentlemen? Isn't that x? So this portion here is what? X. But what is cosine of theta? For that, you got to go back to the definition of cosine. Okay? So cosine of theta, here's my theta. You're going to now deduce. What's cosine theta? Do you guys remember? Adjacent. Good. Adjacent over what? What's adjacent? Hypotenuse. Good. What's cosine theta? Square root of what? 1 minus x squared. So ladies and gentlemen, that's cosine theta. I wish I had the applause button. So you're going to replace cosine theta with what now? square root 1 minus x squared. So, ladies and gentlemen, what does this become? Final answer now. 1/2 the inverse sine of x plus 1/4 x square root 1 minus x squared plus c. And there you go. That's your first integral by trigonometric what? Substitution. Okay? What do you guys think? It's a process, and it's related to u sub. But it's not u sub, it's what? Trig sub. You do x equals sine theta. Generally speaking, a sine theta. Okay, you guys okay with that? Easy peasy lemon squeezy? Yeah. Yeah.
So, I think you forgot the 2 sine theta cosine.
What did I forgot what?
The 2. Like, it should be like
2 somewhere? Is there a 2?
like 2 sine.
Oh, we've got, the 2, sorry, thank you so much. Yes, thank you. What he's saying here, right? This is, where's the what? This 2 makes this what? 1/2. Outstanding. Thank you so much. Because what's 1/4 of 2? 2/4, which is 1/2. Thank you so much. Thank you so much. Even though I had my coffee, it still hasn't kicked in. So there you go. Okay, that's your first trig sub question. So what do you guys think? Easy peasy lemon squeezy? Okay, let's give you guys another example here. Okay, how about if they gave you this? Let's do this here. I want to do something like, okay, well, that one's there. How about, you got to be careful if you kind of make them up. You got to be very careful. Yeah. Anyway, all right. I don't want to make that up, but okay. I can do another similar one. This is similar, okay? Let's give you something that's kind of similar here. If they gave you the square root of 4 minus x squared dx, this is very similar. How is this similar? Do you guys know how this one's similar?
Case 1.
It is case 1. Good. It's case 1. What is the 4 written as?
2 squared.
It's 2 squared. Good. So we're going to integrate what? 2 squared minus x squared dx. So what does that even mean? Okay, so you guys can see your substitution. You know what that really is saying? That's what he's saying. Your a value is what? 2. Good. A is 2, ladies and gentlemen. So if that's the case, it's case 1. X, what do you say x is? 2 what? Is it 2 sine theta? Is that case 1? Yes, it is. Where's our procedure? Okay, see that? A sine theta. That's what you're going to let x be. What will dx be? 2 what? Cosine theta d theta. Is that true? So use the what's in black there. So dx is going to be now this. 2 cosine theta d theta. Okay? What does your radical become? What's 4 minus x squared going to be? What does it say? What did I give you guys here? Oh, I don't think I did. Did I? Oh, yeah, I did. That radical is just going to be a cosine theta. So use that. I would say use that. So that's 2 cosine theta. What does this integral become, ladies and gentlemen? By case 1, we get what? 2 cosine theta. And what's dx? 2 cosine theta d theta here. And what does 2 times 2 give you? It gives you that constant of what? 4. And you integrate now cosine squared theta what? D theta for you guys. Okay? And now, what do you guys want to know? What's that integral? Hopefully you say, oh, I know what that one was. What was that from the last example? Integrating cosine squared, right? Didn't we get 1/2 theta plus 1/4 sine 2 theta? Is that true? So you go, oh, that was 1/2 theta plus 1/4 sine of 2 theta. Yes, there's a constant at the very end, right? So what happens when I take that 4 times 1/2? Doesn't that give me what? 2 theta. And let's distribute 4 times 1/4. So ladies and gentlemen, here you go. Okay, is that right? You guys okay with that one? So far, so good? And then, what do you really have to go back and use? Remember, what did you say x was? X was really what? 2 sine what? Theta. Isn't that how you started this? Trig sub. This is a trig sub. So x is 2 sine theta. So, at this point, you might say, okay, since x is 2 sine theta, you know what that means? That sine theta is x over 2. Is that right? And what does that imply? That implies theta is inverse sine of what? X over 2. So I replace my theta with what? Inverse sine x over 2. But remember, what is sine 2 theta? Wasn't this what? 2 what? Sine theta cosine theta? Is that right? Okay. So let me write this down here. So you guys, let's put it all together. 2 theta plus 2 sine theta cosine theta plus c. What's going on here? This theta we already found. Isn't that inverse sine x over 2 plus 2? What is sine theta again? Do you guys know what sine theta is? Right here, sine theta is what? Replace this with x over what? 2. What's the last thing that I need, though? I need what? Cosine theta. So how do you get cosine theta now, ladies and gentlemen? What do you guys know? You make your right triangle here. Okay, here's my theta. We know sine is, what's the definition of sine? Opposite over hypotenuse. Pythagorean theorem says this is going to be 4 minus x squared here, the adjacent side. It's going to be that radical. What happens with cosine theta then? What's the definition? Adjacent over what? Hypotenuse. Is that true? So this is going to be square root of what? 4 minus x squared over what? 2. And then don't forget you got your plus c. So now 2 inverse sine x over 2 plus x over 2 square root 4 minus x squared plus c. Here's your final answer. Okay, and then that also is a case number what? 1 situation here. Okay, you guys okay with that one? Anybody have any questions on that one here? We okay with that? Do we mess up with a constant at all? I don't think so. I think we're fine. Okay? Give you guys another example here. Okay? How about if they gave you square root now 1 minus 4x squared dx here? Okay, now be very careful with this. Careful with this one. What do we mean by that? That's not the first one we started. That's not even the second one. Is that right? I'm sorry, that wasn't the first. This was the second. This is the first one. We had 1 minus x squared. Is that right? I think so. Yeah. So what do you guys think you want to do here now? Anybody have an idea? The integrals for this technique must involve a radical that looks like what you guys see up here. Okay? How do I know that's case 1, though? It doesn't look like that at all, does it? Yep. You see, isn't 4x squared, can that be written as 2x to the second power? This is really, ladies and gentlemen, this is really a what? This is a u sub situation, where u is 2x. So I'm going to replace this with a u, and you say, oh, is that going to be the integral of the integral of now square root of what? 1 minus u squared. What is dx, though, because it's u sub? du, dx is 2. What does that mean about our dx? dx will be du over what? 2. Okay? So do your u sub. Pull out the constant. So now this is 1/2 integral square root of 1 minus u squared now du. Okay? So I make the claim now. I don't know what color to use. I don't know. Let's use pink. I make the claim now. What do you guys want to do with this? Now this is a case what? Case 1. See what I mean by that? Nice case 1 there. So case 1 integral. So all right, case 1. You go, what do I do with case 1 here? Okay, case 1. There we go, our case 1. It says x is a sine theta. But we don't have x. What do we have? U is, where's our a? There's my what? 1 squared. Isn't a 1? But the variable is an x. It's what? U. So it's, u is what? Sine theta. And then what do you think du will be? Du is what? Cosine theta d theta. What is the radical 1 minus u squared going to be? That's going to be cosine theta d theta. This is the trig substitution. Okay? Trig sub. This is the name of our technique. Don't forget there's a constant out there, 1/2. We might forget, right? Okay. So you guys already know. What does that integral become? This is cosine theta, okay? And then times another cosine theta d theta. And yes, I'm going to keep my 1/2. I'm going to keep bringing it down, okay? So then, yeah, this is 1/2 cosine squared theta d theta. That integral, we know what it is. Let's see, did I copy it? Yes, I did. Good. So you go, okay, we already know what that integral is. But don't forget, it had, because of the u sub, what did it have? The constant 1/2. What does that give you? 1/4 theta plus 1/8 sine 2 theta plus c. Okay, wasn't that? And then what is sine 2 theta? 2 sine theta cosine theta. So now we have that 1/4 theta plus 1/4 sine theta cosine theta plus c. Okay, you okay with that one? So you guys see how that was similar? We use that identity here. All right, what was theta? Right, go back over here now. Be careful though. If u is sine theta, what I know is I can say this. This is u, and then this is inverse sine of what? Oh, u is sine theta? What does that mean? What is theta? Inverse sine of u, right? Inverse sine of u, right in here. What's cosine theta going to be? You go, uh-oh, I don't know. What's cosine theta? Bring out your right triangle. Theta, definition of sine, because it's u over 1. Is that true? So that hypotenuse is 1. The adjacent side will be 1 minus u squared by Pythagorean theorem. So that means cosine of theta is going to be what? Adjacent over the hypotenuse. So we already know that. That's 1 minus what? U squared. Okay, isn't that true? Right? So now you say this is kind of like before. You go, okay, I got that 1/4, not theta, but inverse sine u, plus 1/4 u square root 1 minus u squared plus that c. But be careful, this was u sub to begin with. What did you guys remember? What was our u again? 2x. Is that true? Wasn't u 2x to begin with? Go back. This was originally a what? A u sub question. U was what? 2x. Okay. 1/4 inverse sine 2x. 1/4 2x square root 1 minus 2x squared plus that c. 1/4 inverse sine 2x plus x over 2 square root 1 minus 4x squared plus c. Okay, you guys okay with that one? Easy peasy lemon squeezy. All right, let's kind of look at another case here. Okay, we're going to look at another case. Let's look at case number what? 2. Square root of a squared plus x squared now. Case number 2 here. Square root of a squared plus x squared. We don't want to knock people out. Square root of a squared plus x squared. Now look at your book for an example. Square root of a squared plus x squared. Let me see if I have any good ones here. Okay, how about this one? Yeah, we're going to try this one here. X cubed. Square root a squared plus x squared, we'll say 36 plus x squared dx. Okay? So case 2. square root of a squared plus x squared. Okay? I'm going to say the following. You're going to use x equals a tangent theta. And then what that means is dx is, what is dx going to be if it's a tangent theta?
Secant squared.
Yeah, derivative of tangent is what? Secant squared, keep your constant. And what do you guys think happens with the radical then? What do you think we're going to replace the radical with? Let me prove to you guys what happens with the radical just like before. Well, you got a squared plus, well, if x is, this is going to be a squared tangent squared theta. Okay? Because x is a tangent theta. So this is a square root now of what? Factor out your a squared. You get 1 plus tangent squared theta. Okay? And use your Pythagorean identity. That's going to be a squared times secant squared theta. Which means I have the absolute value of a secant theta. Now, I said it earlier, but a is positive here. Now you say, why is that important? Well, because when you take the absolute value, it's just going to be an a. And then the absolute value of secant is just secant because the angle is in quadrant 1, and all students take calculus, which means quadrant 1, angle between 0 and 90, quadrant 1, that just means cosine's positive as well as secant. So what I want to say is that the radical will always be what? Square root of what? A squared plus x squared. You can replace the radical with a what? Secant theta. Okay, so this is a case 2 trig substitution. I'm going to erase this all. Okay? So then you might say to me, well, how do we handle this? So what are we saying in this here? This is going to be x equals, isn't 36 6 squared? Is that true? So what is our a value going to be? 6. Good. So x will be 6, what? Tangent theta. Then what is dx going to be? 6, what? Secant squared theta. What does the radical then become? 36 plus x squared, the radical is going to be 6 what? Secant theta. Is that true? So, what does this become? You have an x cubed. Be careful here. What was x? So that means I have what? 6 tangent theta cube. What's my radical? 6 secant theta. What is dx? 6 what? Secant squared theta. Okay. Sorry. 6 secant squared theta. Okay? This is the trigonometric substitution. So what do you end up getting, ladies and gentlemen? Double check. Isn't your constant going to be what? 6 to the 5th power. Tangent cube theta. What is this? Secant cube theta d theta. Can I pull out my constant of 6 to the 5th power. Now I got tangent cube theta, what? Secant cube theta d theta? Okay. What do you guys recognize this as right in here? What is this? Huh? Doing an email. Okay. Anybody know, how do you integrate this? Odd power for tangent. Thank you so much. This is why I say the homework on trig integrals is so vital. Without it, you can't continue. You guys see what I'm saying? You're done. So use the odd power. Okay, what did you do there for the odd power? You guys remember the procedure? Odd power. I think you need a factor secant tangent. Is that true? Okay. So I'm going to put this 6 to the 5th integral secant tangent. And then I think we did this one. Is that in our notes? We did this one. What was the answer? See notes. We did this one. I think we did it. Did I change it to a 5th power? I don't remember. Is that in the notes? You guys want to dig that on the notes and tell me the answer? Final answer? Because I can tell you guys the final answer. You guys remember that one? What do we get here? Wasn't this 1/5? 1/5 what? Secant to the 5th theta? Minus 1/3 secant cube theta. But you have what here? It's going to be plus c, but you had the constant 6 to the 5th, didn't you? Was there a constant 6 to the 5th there? Anyway. Okay, let's distribute that. That's going to be 6 to the 5th over 5 secant to the 5th theta minus 6 to the 5th over 3 secant cube. Secant cube theta plus c. Okay, you guys okay with that? But what's the issue with this one again? You got to go back here now. X is 6 tangent theta. We're gonna have to paste this. There you go. What's the issue? You know what this implies? This means tangent theta is x over 6. We need our answer in terms of x, not theta. So we're going to use that fact that x is 6 tangent theta. We're going to create a right triangle. Is that true? And what's the definition of tangent again? Isn't it opposite over what? Adjacent. You know what you get here by Pythagorean theorem? You get 36 plus x squared. You always get that radical. Always. So by Pythagorean theorem, you get the radical. Okay? So now, what do we need? We need secant. Don't we need secant? How do you get secant? You know what I do? I think, what's cosine? Cosine, by definition, is what? Adjacent over my hypotenuse. Is that right? What is secant going to be then? It's a reciprocal. Yeah, just flip that fraction over. Just flip it over. Okay, flip that fraction over. So now you say, what do we get as an answer here? Okay. 6 to the 5th over, what is that, 5? Now, secant is what you guys see here. 36 plus x squared over 6. That's raised to the 5th power. Is that right? Now, that's minus 6 to the 5th power over 3. That radical, 36 plus x squared over 6 to the 3rd power plus c. Now, here's what I would do algebraically speaking. 6 to the 5th over 5 now. I'm going to say, isn't that 36 plus x squared? I'm going to put this as 5 halves, okay? Over 6 to the 5th power. This is going to cancel here. Minus 6 to the 5th power over 3 times 6 cubed. And now I'm going to say this is 36 plus x squared to the 3 halves power plus my constant here. And my algebra says this is 6 squared, which is 36. All right. So you say, what is this? 1/2, 36 plus x squared to the 5 halves power minus 36 divided by 3. Is that 12? Double check my arithmetic, because the coffee hasn't fit in. And in some ways, you're done, ladies and gentlemen. Here's what that is. 1/5, 36 plus x squared, square root of 36 plus x squared. Minus 12, 36 plus x squared, square root of what? 36 plus x squared plus c. This is, some students may want to know what that is. Is that right? And did I screw up on this one? I think there's an issue here. No, I think we're good. This is 6 to the 5th, right? No, we're good. Double check to see if our arithmetic is okay. And some of you guys want to remember this. You guys remember what I did in Calculus 1? 5 halves is 2 and what? 1/2. Is that right? And what is 3 halves? It is 1 and 1/2. In other words, I simplified those radicals. Do we double check? We okay?
36 plus 2x, x squared should be squared, huh? You're finding out answer. Times 36 plus
Which one are you looking at? Yeah, this is squared. Good. Squared, good. 2.5, good. You guys remember from Calculus 1. Did you guys remember that stuff? I mean, I had to go over that, simplifying a radical. Yes, thank you. All right, I'm doing email and I'm multitasking anyway. What do you guys think? Is that? Let me see something here. Well, that one's similar. I don't want to do something like that. It's already similar. What do you have? We have a squared plus x squared. Oh, how about this one here? I don't know if we're not going to have time here. We're not going to have time, but whatever. This is squared. So what is a here? A is 1. What's the substitution going to be? Okay, so I'm saying they can put it as x squared plus a squared. They don't have to have a squared plus x squared. This is case number what? 2. Your book has a star here. So in case 2, what do you guys have here? X will be 1 tangent theta. Okay, so x is tangent theta. That's nice. What's my dx? Secant squared d theta. Okay, what is the radical? Do you guys remember? X squared plus 1. Isn't that going to be just secant theta? Double check. Is that just secant theta what? Secant squared theta d theta? Double check. Is that what it is? That's case 2. Is that true? It sure is. Case 2. Okay. What is this integral going to be? That's secant theta what? D theta. Double check. Am I right about that? Do you guys recognize this? What did I say yesterday? Some of these integrals you want to what? Bless you. How do we integrate secant cube? You use integration by parts. You guys remember that one? See, what I'm saying, what I remembered yesterday, I'll say see your notes, right? So what I did yesterday is remind you guys that some of these things show up and you want to remember those integrals. Like you might have to integrate secant and you go, oh, okay, I know what that is. You might have to integrate cosecant. Oh, I know what that is. What was secant cube? What does your note say? It's in your notes. That was an IBP question. Huh? What is this? Wasn't it like 1/2? Was there a 1/2 there? 1/2 what? 1/2 secant theta, tangent theta. Is that right? Double check. And then that was plus what? 1/2 natural log. Absolute value of what? Is it secant theta plus tangent theta? Okay. There you go. But we go, okay, I integrated that. But what's the deal? X is tangent theta, ladies and gentlemen. So you're going to have to use that fact that X is tangent theta. So that means this portion here is X. That means this portion is X. We need to know what secant theta is. So here's my right triangle. Here's theta. X over 1, opposite over adjacent. Pythagorean theorem says this is 1 plus x squared. Is that true? Okay, Pythagorean theorem. So then we say, I need secant. Okay, so answer cosine. Cosine, by definition, adjacent over hypotenuse, which means that secant is that reciprocal. 1 plus x squared, square root. 1 plus x squared, square root. 1 plus x squared. Final answer, ladies and gentlemen. x over 2 square root 1 plus x squared plus 1/2 natural log absolute value square root 1 plus x squared plus that x. Don't forget to add your what? Constant here. Okay, you guys okay with that? So I have to give the antiderivative not in terms of theta. I always have to give the antiderivative in terms of x. And so there you go, ladies and gentlemen. There's your answer for this particular question here. And that's case number what? 2. Now, let's say Mr. Judge, or not Mr. Judge, whatever. Let's say, where are we at? 262. Calculus 2 worksheets and videos. Oh, where's our trig substitution? Anyway. All right, I thought I had some more examples for trig sub. Maybe I don't. I'll have to check my resources. But ladies and gentlemen, I think I do have some online though. I might give you guys some links. What do you guys think? Should I send you guys some links for more trig sub? So note to self, send you guys more links for trig sub examples. I'll do that. And you know what I try to do today is record this. So I want you guys to see